Hello and welcome to today's lesson, a review of basic data analysis or single variable data analysis. Now, when we're looking at basic data situations or basic data problems, the first thing you want to think about is what calculations could you be required to make within an individual problem. Okay, you might have to calculate a mean value, standard deviation, 5-number summary. Okay, 5-number summary, we've got minimum, Q1, median, Q3, and your maximum value. Range, or IQR, range, distance between max and min. Interquartile range, distance between Q1 and Q3. And then you might also have to do the outlier calculation. Okay, when we're looking at outliers, we've got 1.5 times the interquartile range. Once we find that distance, you can either add it to Q3 or subtract it from Q1. And this is what we call our fence value. So everything after those values on the low end or high end are outliers. But if something falls on that value, it is not an outlier. Okay, it is on the fence. So you have to be over the fence to get there. Now, what graphs are possible? What graphs might you be required to make as a part of one of these problem sets? You might have to do a box and whisker. Okay, remember what a box and whisker shows. It shows 25% chunks of your data. So remember, this low value is the minimum. So that is your full first whisker. Okay, we end up leaving a value by itself to show that it's an outlier in the graph. And then this value here is the last actual data value that is a part of the set. So that's where the whisker stops, and then we show outliers from there. But you want to remember that every one of these chunks represents 25% of your data. So if you have a very small interval in a box and whisker, it actually means that you have a lot of data, 25%, packed into that small interval overall. Okay, now the other thing that you might be required to do is a stem and leaf plot, where you've got your stem as your initial value, the leaves go out from there, and you always want to show a key to show how those values are built. So when we're looking at, some of these first entries, 0, 6, just represents the term 6 as a value. Okay, like we said out here, this value out here is 39. The stem value of your tens digit is a 3, and your ones digit is a 9. Okay, make sure that you include a key with units as a part of that stem and leaf plot. Okay, you could be asked to do a dot plot. Dot plot showing each individual value and what it represents. Very similar to, but different than, the histogram. Okay, the histogram is intervals. So if you notice in this graph, the interval from 60 to 65 has 3 values in it. We don't know if those values are all 60s, all 65s, a couple 62s, and a 61. Okay, so that is the problem with a histogram, is we lose individual values compared to a dot plot where I look at this graph and I know that I have 4 zeros in that space. Okay, now, one of the last things you would be asked to do in a single variable situation is do a comparison or describe the distribution. Okay, so we have our acronyms that we talk about when we're doing those comparisons or descriptions, and we call it SOCS, so S-O-C-S. The first S stands for shape. Is it skewed left, skewed right, normally distributed? Okay, remember the skew is towards your long tail. So this graph would be a skewed left graph, normal, roughly normal, okay, all good terms to use when making descriptions. Okay, outliers or distinguishing characteristics. Okay, if there are truly outliers, you would want to mention that in your description of a distribution, or if there is a distinguishing characteristic, a individual whole value as a part of that distribution. Okay, so if you have a hole in the distribution, if you have a lot of a single value, you would want to put that in as a distinguishing characteristic. Then we need a measure of center. Okay, mean and median are going to be your most common measures of center that you would want to describe. Use what's easiest to get from the information given. And then the last thing we need is a measurement of spread. Standard deviation range, interquartile range. Make sure that the values that you use for center and spread match. If you're using a mean value for center, make sure that you're talking about a standard deviation for spread. Okay, if you're using a median value, make sure that you use range or interquartile range. Now, mode as a measure of center is not used too often, but it is something that you can describe overall. Okay, now, the next thing that you would want to be able to do going into any individual test is be able to use any of the calculator operations to make your life easier. Okay, most of your calculator operations are housed within the stat button. Okay, what we would want to do here is we would want to be able to enter a data list. So if we have any list of data, and I'm just plugging in some random values here to work off of. Once we have that data list, we can go back into stat and we can do all of our calculations. Okay, so we've got our calculations, one variable, two variable stats, some other calculations that we'll look at in other lessons. But if I want to do a one variable statistics on this, okay, this will give me all of my critical values. Okay, X bar is your mean value. Okay, so we have our mean value here. Okay, standard deviation. Remember the difference between the two standard deviations. This is for a sample standard deviation. This is for a population standard deviation. Okay, we also have sample size down here, n equals 6. And then when we look at the lower values, there is our 5-number summary. Min, quartiles, median, max. Okay, all there, real quick, real easy for you to grab and use overall. Now, if you're needing to make a distribution, to make any distributions, we need one other function that we can go into to do. Okay, and that would be our second y equals to get into the stat plot. Those are our fantastic bells from one class to another. Okay, so you want to turn the plot on, pick the type of plot that you're wanting to work with, okay, whether it's a scatter plot, histogram. Okay, most often the only time we really use this plot much is for our box and whisker plot, and you would want to select this first one that's blinking here right now, because that would be a box and whisker plot that shows you outliers. And notice, it'll tell you right where to put your data. Okay, so everything's set here. And then what we want to do right away is go zoom. And then if you notice down at number 9, it's zoom to our stats. And then here's your box and whisker. And then you can use the trace button to go through and look at any of the values that you would need to describe or talk about. Or if you had to make a box and whisker, here is the image of it, and you would just want to copy this and label the graph appropriately. Okay, so that is our quick review of single variable or single data statistics. Thanks, and have a good day.